Hello everyone. My name is Nehal Yadav, studying in third semester USN 1VE 23 CA033. My department is CSE and today's subject is mathematics. And today we'll be learning about the topic Introduction to Markov Chain. The subject code is BCS301. So what do you mean by a Markov chain? So a Markov chain is a type of a stochastic process that models a sequence of possible events in which the probability of each event depends only on the state attained in the previous event. This property, known as the Markov property, implies the process has no memory behind the current state. So in a Markov chain, so states represent the different possible outcomes or situations. So transition probabilities determine the likelihood of moving from one state to another. So time steps can be discrete, example days, turns, etc. With each step involving a transition based on these probabilities. So what do you mean? So a Markov chain is a stochastic process so that models a sequence of possible events in which probability of each event depends only on its state attained the previous event. Only then will be called it as a Markov chain, and this property is usually called as the Markov property that impress has no memory beyond the current state. So a classic what is an example of a Markov chain? So a classic example of a Markov chain is a board game where the chance of landing on a space depends only on the space where the current player stands, not on how they arrived there. So this is how well the past so the previous event depends, which is called as Markov chain. It's a board game where the chance of landing on a space depends on the other player who landed before. So this is nothing but a Markov chain. So what are the basic concepts in a Markov chain? So here are some of the basic concepts in a Markov chain. So first one, states. So these are the possible conditions or configurations the system can be at any given time. So in a simple Markov chain, states are usually labeled with numbers or letters. Example 1, 2, 3 or A, B, C. So second one, transition probability. So the probability of moving from one state to another is called the transition probability. So what do you mean? So it's a in Markov chain. So these probabilities are typically represented in a transition matrix, where each entry represents the probability of moving from one state to another in a single step. So third one, so transition matrix. So the transition matrix is a matrix that holds the transition probabilities between states. So if the chain has states, then the transition matrix will be a matrix where the entry in row and column represents the probability of moving from one state to state. So fourth one, so initial state and initial distribution. So the initial state is the state that the process starts in. So the initial distribution gives the probability of starting in each state if there is more than one possible starting state. So fifth one, Markov property. So what is this Markov property? So this property states that the future state depends only on the current state, not on the sequence of the states that preceded it. So this is often called the memoryless property. So this is a bit different. It's called as memoryless property. So sixth one, steps or these are also called as transitions. So a step represents a movement from one state to another governed by the transition probabilities. So seventh one, so steady state distribution. So this is a probability distribution over the states that does not change over time if the Markov chain is in equilibrium. So if the chain reaches a steady state, it means that the probabilities of being in each state remain constant over time. So these are basic concepts in a Markov chain which are used. So first one is states will come can be at given time. Second one is transition probability which move from one state to another. So third one is transition matrix which hold the transition probabilities between states. So fourth one is initial state and initial distribution where the process starts in. So fifth one is a Markov property which we have already seen. So sixth one is the steps, and seventh one is the steady state distribution where it does not changes over time if the Markov chain is in equilibrium. So Markov chains have several important properties that characterize their behavior. So here are some key properties along with example. So first one is Markov property which is known as memoryless property. So the probability of transition to the next state depends only on the current state, not on any prior states. So what is it? So this we have already seen is a definition of Markov property. So example, consider weather patterns where if it's raining today, the probability of it raining tomorrow depends only on today's weather, not on previous days. So this is a perfect example for Markov property. So second one, transition matrix. So this definition, a matrix representing the probabilities of moving from one step to another in one step. So, example, suppose a two-state Markov chain represents whether a machine is working state 1 or broken state 2. If the probability of staying working is zero point 0.9 and of breaking down is zero point 0.1, the transition matrix might look like zero point 0.9 and zero point 0.1 hash slash zero point 0.4 and zero point 0.6 hash slash end for our bracket P matrix. So the third one is irreducibility definition. So a Markov chain is irreducible if it's possible to get from any state to any other state, perhaps over multiple steps. So example, in a board game where you can move forward or backward between any positions. So every position is rechargeable from another, making the chain irreducible. So fourth one, periodicity. So a state has a period if it is can be called by revisited of at multiples of a certain number of steps. If it is number of one for all states, the chain is aperiodic. So example, consider a Markov chain where you alternate between on and off states in a device. So each state can only be revisited every two steps, so it has period of two. Each state could be revised at any step. It would be aperiodic. So fifth one, transient and recurrent states. So transient state, a state is transient if there's a chance the chain will leave and it never return. Recurrent state, a state is recurrent if once entered, the chain will return to it eventually. Example, if a random work when you start at position 0 and can move left or right. Position 0 is recurrent because you'll keep returning. However, if there is an endpoint on one side, states leading up to this endpoint might be transition since you could leave and not return. So sixth one, absorbing state definition. A state is absorbing if once entered the chain cannot leave it. Example, in a game where reacting the final leave ends the game, this leave is an absorbing state because once reached you can't transition to any other state. Stationary distribution. So a distribution over states that remains constant over time as the chain progresses, meaning the probabilities of being in each state no longer change. Example, in a Markov chain representing long-term web traffic on different pages, the steady case state distribution would show the proportion of time spent on each page in the long run regardless of the starting page. So the eighth one is ergodicity. Definition: a Markov chain is ergodic if it's irreducible, aperiodic, and has a stationary distribution. In this case, every state can be reached from any other and over time. The chain will settle into a steady state distribution. So example, in a social network model where every user connects with any other user through friends or friend, the chain is ergodic. Thank you.